So, hello students, today we see some more problems in stoichiometry. Okay, first see the how many moles of hydrogen peroxide will be required to react completely with 1.5 mole of this is a potassium tetrahydroxychromate. So actually it is a complex compound. Its name is potassium tetrahydroxychromate 1 in basic medium. So already know these when two compounds react completely, we need to equalize their Milli equivalents. Okay. So here what is the first we see what changes takes place. So here we know that potassium there is no change. Potassium always plus 1. So here potassium plus 1 means what is the change? The changing in the complex ion. So this is H minus chromium tetrahydroxide ion. Chromium tetrahydroxide ion. So actually it changes to changed it to CrO4 minus 2. That is chromate ion. Okay. So now we see what is the N factor. So what is the N factor here? What is the chromium oxidation number? So here what is the X minus 4 equals minus 1. So X equals plus 4. Chromium is in plus 3 state. Here what is the X equals X minus 8 equals minus 2. So chromium is in plus 6 oxidation state. So automatically so there is one chromium and oxidation number increased. Oxidation number increase means it is oxidized. So oxidation means it loses electrons. How many? 3 electrons. Means here N factor. So N factor is equal to 3 electrons. So because to know the milli. So okay, next. So what is the change? The change in hydrogen peroxide. So it is important the change in hydrogen peroxide in basic medium. So this is also a separate one. We have to remember that hydrogen peroxide in basic medium. Function. So this is understand. The hydrogen peroxide changes to H2O. Okay. So what is the N factor here? Each oxygen, there is no change in the hydrogens, but here we are discussing about the change in the oxidation number of oxygens. So carbon balance cells number of oxygens. So hydrogens already balanced. So but we balance only oxygens. So there is no need to balance the hydrogens because here we are balancing the atoms which undergoes oxidation or reduction. Okay. So oxygen is important. 2 oxygens, each oxygen oxidation number minus 1. So normal we know that each oxygen normal oxidation number minus 2, minus 1 to minus 2. 2 oxygens like this minus 1 to minus 2. So totally, so how many electrons gaining of 2 electrons takes place. So what is the N factor? So here N factor equal to 3. So here one more important madam. So normal the milli equivalents equal channel. We have to equalize the milli equivalent of both the compounds. Both completely reacting and milli equivalents of hydrogen peroxide equal to milli equivalents of these complex compounds. The milli equivalents concept just if molarity is given. Okay, look at that. Direct the normal N1 V1 equal to N2 V2 use system. But here it is given in terms of moles. మనం find out చేయాల్సిన moles మనకి ఇచ్చిన information also in terms of moles. కాబట్టి so N factor తో మనం direct గా moles చేయొచ్చు. So the chromium. So actually question మనం find out చేయాల్సింది how many moles of H2O2. Okay. Here hydrogen peroxide exactly equal with the సో మిల్లీ ఈక్వలెన్స్ ఇస్తే మనం డైరెక్ట్ గా చేసేస్తాం. ఓకే, సో మిల్లీ ఇన్ టర్మ్స్ ఆఫ్ మోల్స్ ఉంది కాబట్టి డైరెక్ట్ గా n ఫ్యాక్టర్. సో వాట్ ఇస్ n ఫ్యాక్టర్? ఇట్స్ n ఫ్యాక్టర్ ఈక్వల్ టు 2. సో వాట్ ఇస్ n ఫ్యాక్టర్ ఈక్వల్ టు 6. సో sorry 3 means directly we can write 1 by 2 moles. With the help of this we are able to convert them into moles. Okay, so here 1 by 2 moles of hydrogen peroxide required need. Okay, 1 by 2 moles of exactly one reverse reciprocal this we will get the moles. So 1 by 2 moles of hydrogen peroxide is required for the reaction of need is required for 1 by 3 moles of this complex potassium tetrahydroxychromate. Okay, so this statement is obtained with the help of n factor. So 1 by 2 moles of H2O2 required for 1 by 3 moles of this complex. Then what about for 1.5 moles required how much hydrogen peroxide? Okay, so here actually we have to find it for 1.5 moles. So 1 by 2 moles of H2O2 is required for 1 by 3 moles of this complex. Then what about so how many moles of H2O2 required for 1.5 mole of this potassium tetrahydroxychromate 1. Okay, so we can write just on cross multiplication this is 9 by 4. Okay, means 9 by 4 mole of H2O2 is required for the complete 9 by in terms of moles direct we are writing like this. Okay, so 9 by 4 moles of hydrogen peroxide is required to complete react with the 1.5 moles of the potassium complex. Okay, so now we see one more problem. So here it is one more very important problem. So that what volume of potassium permanganate is required to oxidize. Already we know potassium permanganate is a good oxidizing agent. So what volume of potassium permanganate is required to oxidize 100 milliliter of 0.3 m molarity is given ferrous oxalate in acidic medium. So just what is the difference in the loss cessation problem and this problem? Loss cessation also we done some problems to calculate the value in terms of milli equivalents. Molarity ichundu value ichunante we are able to we have to calculate that problem in terms of milli equivalents. So milli equivalents cheyali. So but what is the difference in this reaction is so ichina compound manaki so here potassium permanganate. So no change, no doubt in it. Potassium permanganate in acidic medium changes into Mn+2 n fact equal 5. Directly we can write. But what about this ferrous oxalate? Actually ferrous oxalate low. So there is a ferrous ion is also undergoes oxidation. ferrous ion undergoes ferric oxidation. So C2O4 minus 2 oxalate. C2O4 minus 2 also undergoes oxidation, changing into CO2. And here, so oxidation involved by species to 2 ఉన్నాయి కాబట్టి మనం 2 species కి reaction రాయాలి. Okay, so first see, first in acidic meaning కాబట్టి so what is the change? Potassium permanganate lo permanganate ion it changed to Mn plus 2. Already we know that we already calculated many times. So here what is N factor? N factor equal 5. We know the manganese oxidation number, calculate this way, we will get 5. So x equals 5, 7 is plus 2. So the difference in the number of electrons plus 2. Here plus 7 becomes plus 2 means it is reduced. So by gaining how many electrons? 5 electrons. Means 5 electrons plus MnO4 minus. Next. See, change in the second species. The second species change there. So Fe. Here Fe condition, Fe plus 2. We know that it is Fe plus 2, C2O4 minus 2. Oxalate. Fe plus 2 in any medium. Actually in acid medium it changes to plus 2. Plus 2 changes plus 3 means it takes place by losing 1 electron. And here in the same species oxalate is present. We know that in acidic medium oxalate is changed to CO2. Here we are comparing the oxidation number of carbon. Here OK minus 2, here OK minus 3. No comparison for it. So I can compare the carbon oxidation number. The number of carbons is called 2 carbons, 2 carbons. So then what is oxidation number of carbon here? 2x minus 8 equal minus 2. So each carbon is present in plus 3 oxidation state. Here each carbon is present in the plus 4 oxidation state. So totally how many electrons? 2 electrons. One carbon changes from 3 to 4, second carbon also changes from 3 to 4. So total 2 electrons. And on the oxidation process, in the oxidized compounds, so total how many electrons losing of 3 electrons. Here 2 electrons, here 1 electron. Here both combined with ferrous oxalate law. So in fact it was 3. So okay, but in terms of we have to find the value, and given in terms of value and molarity kabatti, so we know that milli equals equal cheyali. So just remember the N factor. So milli equivalence of potassium permanganate is exactly equal to milli equivalence of FeC2O4. What is the milli equivalence? Normality into volume. It's normality into volume. So normality means again it is given in terms of molarity. Molarity into N factor into volume. Same for its for it also molarity into normality into volume. Actually so 1 N1 and M1 N1 M2 N2. Okay, no problem. So here potassium permanganate తీసుకున్నాం కాబట్టి so మళ్ళీ 1 2 అవసరం లేదు. Okay, potassium permanganate volume how much? We have to find out the potassium permanganate. Next is required to oxidize 100 milliliter of 0.3 m. Next, what is the normal? So N factor is how much for oxalate? 3. What its value? 100 milliliters. So here we don't know about the molarity. So M into N into actual మనం find out చేయాల్సింది ఇక్కడ volume find out చేయాలి. Okay. Is it given in the problem? Just wait. I think the molarity is missed in the problem. So again I will check the problem. So it is given 0.1 m potassium permanganate. Change it in the problem. In the problem itself it is given 0.1 m. In the problem it is given 0.1 m. Molarity of potassium permanganate 0.1 m. N factor is 5. We have to find the value. So the value equals 5. So get cancelled. So finally we will get how much? 180 milliliter. So 180 milliliter of potassium permanganate. 180 milliliter of potassium permanganate is required to oxidize the 0.3 m 100 milliliter of ferrous oxalate. Okay. Okay, same. So related to the first problem. So how many moles? So how many moles of ferrous oxalate are required to reduce 2 mole of potassium permanganate in acidic medium? So already we know same problem, but it is given in a reverse reaction. So actually the potassium permanganate required is the question. Here we have to find the ferrous oxalate. Again, that problem was given in terms of molarity and value. It is given in terms of moles. Means it is simple one. So already we know what are the N factors for ferrous oxalate? FeC2O4. In FeC2O4 we know that Fe plus 2 become Fe plus 3, and oxalate C2O4 minus 2 become 2CO2. So this is plus 1 electron, this releases 2 electrons. Here total N factor, so just now we done it. N factor equal to 3. So next, what is the potassium permanganate? It is given exactly acidic medium. So in acidic medium, so MnO4 minus will change it to Mn plus 2. So by taking 5 electrons, means the ferrous oxalate works as a reducing agent. We know potassium permanganate is the oxidizing agent, so automatically the other one works as a reducing agent. So always ferrous oxalate, just remember, always ferrous oxalate works as a reducing agent. So 5 electrons, here N factor is equal to, so 5. So it is given in terms of potassium permanganate. So FeC2O4 potassium permanganate. So what is the N factor for here? So actually so direct we can equalize them. So one equivalent of this react with one equivalent of this. So in terms of N factor, we can write it into 1 by 3 here. So what is N factor? 3. So N factor equals 5. So N factor system, we know that we can convert into moles. How do you convert into moles? So therefore here we can say 1 by 3 mole. So 1 by 3 mole of FeC2O4. FeC2O4 reacts with nothing but reduces. We can write reduce. So problem given in terms of reduce. So reduces so 1 by 5 mole of potassium permanganate. So it is according to their N factors. But the problem it is given that how many moles of ferrous oxalate is required to reduce how many moles it is given? 2 moles. 2 moles of potassium permanganate. Okay. So 2 into 1 by 3 the total. So 1 by 5. So one overall calculation. 10/3 moles of FeC2O4 is required to reduce the given potassium permanganate. So answer we can simplify based on its options. Okay. Okay, see the next one. So 100 milliliter of X molarity. Here molarity is not given. X molarity of potassium permanganate is required to oxidize 200 milliliter of 0.2 molarity ferric oxalate. So my last semester 2 problems though it was about ferrous oxalate. It is given ferric oxalate. So ferrous oxalate, ferric oxalate generally both undergoes oxidation and works as the reducing agents in acidic medium. We have to find, so what is the normality of potassium permanganate? Means it's normality. So actually my molarity is directly into n factor chesi we will get the normality. But molarity kuda just x and ichina man mundu molarity find out cheyali. So after calculating molarity we can calculate the normality. So already the completion of reaction completed, and we can equalize the milli equivalence. It is given in terms of values lo undi, molarity lo undi kabatti manam equalize cheyalsindi milli equivalence. So first we will see n factors. So we know potassium permanganate MnO4 minus is changes to Mn plus 2 in acidic medium. What is the n factor? So we know it's 5 electrons. So in the last problem we discussed how it is 5. So 5 electrons, so n factor is equal to 5. So here what is the ferric oxalate? The ferric oxalate formula, you know that ferrous means Fe plus 2. So ferric means Fe plus 3. So Fe plus 3 kabatti C2O4 here. So మనకు ferrous oxalate no doubt Fe plus 2 C2O4 minus simple గా సరిపోయింది. But actually the C2O4 minus 2 Fe plus 3. We know in the writing of a formula we have to follow the crisscross method, the balancing of positive charge and negative charge. So we have to take Fe2 C2O4 taken 3. So this is the formula of a ferric oxalate. So దీంట్లో oxidize అయ్యే part only ఒకటే C2O4 minus 2. Only C2O4 minus 2 oxalate and only undergoes oxidation. So ఇంతకుముందు in the last problem that was ferrous. So అక్కడ ferrous కాబట్టి ferrous is having chance to oxidize into ferric. ఇక్కడ only it is in the condition of in the state of ferric కాబట్టి దీనికి oxidize అవ్వడానికి ఛాన్స్ లేదు. So ఇక్కడ oxidize అయ్యే part only C2O4. But C2O4 minus 2 ions are how many are there? 3 are there. We have to consider the total ions. Okay. So 3 C2O4 minus 2 ions. We know that C2O4 minus 2 ion changes to carbon dioxide. So balancing carbon dioxide. So balancing carbons, 6 carbons, 6 carbons. So what is the oxidation number? Just C2O4 minus 2 to CO2. No, 1 electron. Total how many carbons? We are writing again. So, but into 3 afterwards we will do it. So x equal 3. So how many carbons are there? 6 carbons are there. Here we know x equal we will get 4. 3 becomes 4. Like this, how many carbons? 6 carbons become from plus 3 to plus 4. So 6 carbons plus 3 to plus 4 they lose 1 electron each. So total here in fact that is 6 electron. N factor is equal to 5. So the reaction is have to come is required total oxidation. So total oxidation we can write so milli equivalents of potassium permanganate is exactly equal to milli equivalent of ferric oxalate. So knowing the formula is also very important in these problems. Without knowing the formula we can't do it. So milli equivalence we know that molarity into n factor into its value. Say molarity into n factor into its value. So what is the molarity? We don't know. Just we are writing as x. What is n factor for potassium permanganate? 5. What is its value? 100 milliliter. What is the molarity of ferric? It's 0.2. What is its n factor? 6. What is its value? 200. That's the expansion. Okay, so we can write 0.2 into its 12. And finally, we will get how much molarity? So molarity. So 224. So it's by 10. Okay, 24 by 10. So actually x is not the answer. Normal to convert to next calculation. Just we left it as like this. 24 by 50 is the molarity. Okay, molarity. Let's convert it into normality. So you remember the relation between molarity and normality? So itself in the formula it is there. Actually milli equivalence means normality into value. But in the normality place flow it is given in terms of molarity covered m into n as well. So therefore normality equals molarity into n factor. Okay. So next normality of potassium permanganate equal to, here we are discussing about potassium permanganate. Okay, how much you want molarity? What is the n factor? N factor, we know that there is a 5. Is the change in the number of electrons 5. So simple. N equals, that is 2.4 normality. So the normality of potassium permanganate was 2.4. Okay, just what is the main key point to do this type of problems at it? So first we have to know which is oxidized and what is n factor for it, which is reduced, what is the n factor it. Normally the given compounds lo one reduce outundi, one oxidize outundi. But sometimes in the given two compounds lo actually in any compound one species undergoes reduce or oxidize. But in some species there is a possibility of oxidation or reduction by two species. So that's find out this call. You have to remember that. Okay. Next, it is given in terms of volume and molarity. We have to equalize the milli equivalence. Otherwise, number of moles, we have to equalize the equivalence. Just by the reciprocal of their n factor, we will get the moles. Moles equalizes, we will find out the question number, question moles. Okay.